Hi, Algebra. In lesson 3 here, we're going to be seeing these tables again that we saw at the beginning of the year, but we're going to be using them to keep track of some more things. So here we go. So a quick refresher on these tables. When they say think of a number, that's just going to be represented by a bucket, or abbreviation-wise, just the B, because we don't know what's in there, right? The bucket could be holding anything. Next step here, we're adding 5. That's going to be adding on those 5 dots, and we see B plus 5. Then we're going to be multiplying by 6. Here, we're going to start adding in some more abbreviations. Instead of drawing out 6 buckets and 30 dots, I'm just going to write 6 buckets and 30 dots. So that means we multiplied everything by 6. Here's what you end up with when you finish the rest of the table. Go ahead and fill in these rows. Here's what these columns end up looking like. You may have noticed in the last 2 columns that you kind of had to work backwards as you go. So that was a little bit unique there, but it is doable with the instructions that you're given. Here's what these 3 boxes end up looking like, so check your work there. The thing we want to focus on is right here, the difference between Lena and Jay's expressions. So right here, Lena wrote it as 3b plus 12, which is what we see. Jay wrote it as 3 times b plus 4, or 3 groups of b plus 4. So he took this b plus 4 and just multiplied it by 3 by writing the whole thing times 3. Lena took each part times 3, the b times 3 and the 4 times 3. So that's just very different, and then they wrote this next part different as well. Jay just took what he had first and subtracted 10. Lena subtracted 10 from the 12. Now they're both correct, it's just different ways of writing those expressions. Okay, so here's those steps written there. Number 4, we want to take this and write it using the area model. So 5 times 2n minus 3. So here's another way to write this step right here. I'm going to add it in here as 10n minus 15. Then if we add 16 to this, I could take that 16 and add it to the like term of negative 15, and I would still have 10n. Negative 15 plus 16 is going to be a positive 1. So over here, number 5, another way to write that last expression would be 10n plus 1. In number 6, if we get 71 as our result here, what number did we start with up here? Well, over here, this box, I want you to circle this. It's the same as looking at the equation. It's the same as saying this equals 71, or this is much more simple, 10n plus 1 equals 71. So let's write that down and work through it. So if 71 was the final number, what number did we start with? Or in other words, what is n? Using our steps of solving an equation, we have to do the same thing to both sides. I want to get that n by itself. So I'm going to subtract 1 from both sides and end up with 10n equals 70. Divide both sides by 10 because n is being multiplied there. And I get just 1n because 10 divided by 10 is 1. N equals 7. In number 7, if we start with a number x and we add 4, that would be x plus 4. The next step, we're multiplying by 3. I could multiply each part by 3, x times 3 and 4 times 3, but they're writing it as 3 times, in parentheses, everything we just had. So that would be 3 times x plus 4. And then we're going to divide by 2. That means we're dividing everything we just had by 2. So everything we just had was 3 times, in parentheses, x plus 4. And then subtracting 9 from the result means everything we just had minus 9. So adding in what we just had, it'd be 3 times, in parentheses, x plus 4, divided by 2, minus 9. Starting with the number k, if I look at what we're doing right here, that's going to be subtract 3. Then we divide by 4 in the next step. Next step here, we are adding 7. And then lastly, we're multiplying all of that by 8. All right, guys, there you go, working with some more advanced instructions for equations and more advanced ways to write them. Make sure you're asking questions if you need. Go on to the practice problems. You got this.